Boyle's law relates pressure and the volume for a given gas at constant temperature and the amount of a gas. So Boyle's law states that for a fixed mass of a gas, pressure is inversely proportional to the volume at constant temperature. It means the pressure is inversely proportional to volume provided we keep the number of moles constant and the temperature constant. And this proportionality constant is given the symbol K, where K is a constant and is a characteristic of a given gas Now we can also write the pressure into volume product is constant. So we have these three equations. This is called equation number 1, this is equation number 2, and this is equation number 3. And we can also take the log of this equation on both sides. So we can write log of P plus log of V is equal to log of K. Or we can write log of P is equal to minus log of V plus log K. So this is our fourth equation. And we can show the graph, we can also explain the Boyle's law graphically. When we plot a graph between the pressure and volume. So pressure on the y-axis and volume on the x-axis. So we have a graph like this. So these are the three graphs at three different temperatures, T1, T2 and T3, where T3 is greater than T2, greater than T1. This is a graph on the based on equation 1. We have a second graph based on equation number 2, in which we plot a graph between the pressure on the y-axis and the 1 by V on the x-axis. Now this graph is a straight line with a positive slope. And the slope of this line is equal to K. So this is the graph based on equation number 2, a graph between pressure and 1 by V. Then we have a graph based on equation number 3, product of pressure and volume on the y-axis and the pressure on the x-axis. Now this graph is a straight line parallel to x-axis, because changing pressure will change the volume, but the product of pressure and volume remains constant. This is based on equation 3. Then we have a fourth graph, which is the graph between the log of P on the y-axis and log of V on the x-axis. Now this graph will be a straight line but with a negative slope, and the intercept in this case is equal to log of K, and the slope is equal to minus 1. So all these, this is a graph for equation number 4. These are graphical representation of the Boyle's law. And the graph between pressure and volume at constant temperature is called pressure volume isotherm. Isotherm is the temperature is kept constant. For any two states, for the same gas at same temperature, we can write P1 V1 is equal to P2 V2. Now let us solve one question based on Boyle's law. The question is a flask of 120 ml capacity containing a gas at 750 mm mercury pressure at 20 degrees Celsius has been transferred to another flask of 180 ml capacity. Another flask of 180 ml capacity at same temperature. Calculate the new pressure. Exerted by the gas. Now, since the temperature is constant, so we have to use the Boyle's law. So initial pressure was 750 mm mercury, and the initial volume occupied by the gas was 120 milliliters. Now the gas has been transferred to another flask where the gas is occupying a volume 180 ml. We have to find the final pressure. So we apply Boyle's law that P1 V1 is equal to P2 V2, and we can write 750 into 120 is equal to P2 into 180. So we can calculate now the final pressure. This is 750 into 120 upon 180. So the final pressure the gas will exert is equal to 500 millimeters of mercury. This is the final pressure. So when the volume is increased to 120 ml, pressure is reduced to 500 mm mercury from 750 mm mercury. We have another question that 200 ml of a gas exerts a pressure of 740 mm mercury at 20 degrees Celsius. Now if the pressure is increased to 1.5 times the initial pressure at the same temperature, then find the new volume. Now this is again the numerical based on the Boyle's law. Now initial volume given is 200 ml. Our aim is to find the final volume. Now initial pressure was 740 mm mercury, and the final pressure is 3/2 times the initial pressure 740 mm mercury. Now we apply the Boyle's law that P1 V1 is equal to P2 V2. So we write 740 into 200 is equal to 3/2 into 740 into V2. Now this 740 gets cancelled. So the volume is equal to now 400 upon 3, and this final volume is equal to 133.33 ml. So when the pressure is increased to 1.5 times the initial pressure, the volume is reduced to 133.33 milliliters. And the next is that as we go to the higher altitudes, the pressure decreases. So the volume increases, and when the volume increases, the density of air decreases. So it's more difficult to breathe at a higher altitudes. So that's why the mountaineers have to carry oxygen cylinder with them, oxygen cylinders with them.